Hello viewers, I'm Kausalya. Today we are going to solve problem number 4 and 5 under the topic AC parallel circuits. So here the problem is the total current I in the figure is 20 with an angle of 30. Find the potential difference between the points A and B. So here this is your given problem, right? It has two branches and the current flowing through this branch we are taking it as IA and this branch as IB, and this is your total current. So here you are asked to calculate the potential difference between the points A and B, right? So initially we are starting with the calculating the values of currents IA and IB by using the current division formula, right? So how we can write the formula? Just to refresh, you see, to calculate IA is given by the total current I, right, multiplied by the opposite impedance. So here what is the opposite impedance? We are going to calculate IA here. So the opposite impedance is, this is your opposite impedance and this is nothing but ZB, right? So total current I into opposite impedance divided by the total impedance. So here we are considering this impedance value as ZA and this impedance value as ZB, right? So here again the value of total current I is given in the problem, right? And ZB, that is the total impedance in the second branch. So you see here the value of ZB is nothing but, here both are inductive reactances. So therefore J3 plus J9. So J3 plus J9, that gives the value of J12 here, right? And again when you look at here, ZA is nothing but, here these two are resistors, so just we can directly add. So 20 plus 15 will give the answer as 35 ohms here, right? So we know the value of ZB as J12 and ZA plus ZB, just you have to add. So that gives the answer as 35 plus J12 here, right? Now this polar form is converted into rectangular form here and we are going to simplify our calculation. So once everything was done, you see the value of IA is calculated as 6.48 with an angle of 101 amps, right? Now we are going to calculate IB. So again here what is the formula? IB is given as I into ZA divided by ZA plus ZB, right? And here the total current is 20 with an angle of 30 and here the ZA is 35 and the total impedance is 35 plus J12. Again we are doing the same. We are going to convert this polar form to rectangular form here and we are going to simplify that. So once you simplify, you see here the final answer is 18.91 with an angle of 11 amps, right? So here we are asked to calculate the voltage drop or potential difference between the points A and B, right? So here EAB can be written as EAP plus EPB. Let me show you how. So you see the potential difference between this, okay, these two junctions, EAB is nothing but it is EAP plus EBP, right? So the next thing is, you know, EAB, it can be written as EAP. Here you see I am just reversing, therefore minus EBP, right? So when you substitute EAP and EBP values, then everything was fine. We can easily calculate the potential difference between points A and B, right? So therefore EAP, it is nothing but IA into 20. Again we have to look back at the problem. You see we need EAP. So here the current flowing through this is IA, right? IA into 20 will give you this AP, right? And similarly IB into this J9 will give you the value of BP, right? So again EAP is IA into 20, right? We know what is the value of IA, just multiply. Similarly EBP is given by IB into J9. So once we are done with EAP and EBP, just substitute it here in this expression. So once you substitute here in the expression, the answer is minus 40 with an angle of 101 degrees. Right. So minus 40 can be written as 40 with an angle of 180 degrees. Okay. Right. Plus this angle as 101 degree. So now when you add, the final answer is 40 with an angle of 281 degrees. Right. And again, since we are having 281 degrees, we are going to subtract this. That is 281 minus 360 degree. That gives the answer as minus 79 degrees. Right. So here, since we need the value of voltage, that is magnitude, to be a positive thing, here we are including all these parameters. Right. So here the answer is 40 volt. Right. So the problem ends here. We will move with the next one. Two circuits, the impedances of which are Z1 and Z2, right, are connected in parallel. If the total current supplied is 15 amps, what is the power taken by each branch? Right. Here we know Z1, we know Z2, right? The total current is given. We have to calculate the power consumed by each branch, right? So Z1 is 10 plus J15 and Z2 is 6 minus J8, right? First, write down the given parameters. Okay, we are representing it in the polar form also. So again, we are going to use the current division rule. So because to calculate power, we should know the value of current that flows in each branch, right? So how to calculate I1? As usual, I1 is calculated as total current I into opposite impedance Z2 divided by the total impedance Z1 plus Z2, right? So which is given as, you see, we know the value of current, total current that is given in the problem. We know the value of Z2 as well as Z1, right? So just substitute it over here, right? Here we are representing it in polar form, right? This is in polar form. So I am representing this Z2 also in polar form. So you see, here again Z1 plus Z2, we are simplifying this and we are getting the answer like this. Now we are going to convert this denominator part in polar form. So when you did this, you see here we are getting terms like this, and once you simplify this, the value of current is given as 8.6 with an angle of minus 76.76 amps, right? And to calculate I2, you see, you can either make use of current division formula one more time, or you can directly make use of this one, because we know, right, here I is divided into 2 as I1 plus I2, right? We know the value of I1, we know the value of I. Therefore, simply I2 can be written as I minus I1, right? This is the easiest form. Okay, rather than using the current division formula one more time, you can make use of this. So just as usual, substitute the values, and finally we have to find out what is the value of I2, right? So power consumed by first branch, it is given by the formula. Power is I square R. So here it is I1 square R1. We know the value of I1, and what is the value of R1? It is given in the problem, right? You see, this is your value of R1 and this is your value of R2, right? R1 is 10 and R2 is 6. So just substitute it here. So here the answer is 739.6 watts, and power consumed by the second branch is, again I2 square is 15.5 whole square into 6. The answer is 1442 watts, right? So here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.